Perfect. Okay, so that recording's going now. Tangent is sine over cosine. So I'm trying to think of domain, what we can plug in, where we have issues. Well, if I have a fraction, what is the thing that we're looking for to happen to avoid issues if I'm dividing? I can't divide by what number? 0. So I'm looking for when is cosine 0. So cosine, calling 911. Where is cosine 0?
Where did you say the x-axis was in?
It should be like, do you see the big stack? They're all getting like intertwined. I'm going to fix them in the next little bit. I think right. Maybe one more over. I'm getting some boxes for these. There you go. Chapter 6. So they'll be in here. This is pre-calc 1. Oh, 6.4, 6.3. Yeah, they're all right here. All right, sine over cosine. Here we go. Cosine's which variable? X. Okay, so if I'm thinking of my unit circle, right, I have my circle, and I'm thinking of X, I'm thinking of all my angles where X is 0. So X is left and right, right? So we want to figure out when do I not go left and right? Well, that's going to be the angle that goes up, right? It's right here. If I have that angle here, the X is 0. What is that angle? 90. And then we want to start thinking of radians as well, because that makes the unit circle easier. What radian angle is that? Pi over 2, right? All the way over would be pi, so I just cut it in half. So I know that cosine, what we're trying to find is that cosine of theta is 0 when theta is pi over 2. Is there another angle that cosine would be 0? 3 pi over 2. It's down, right? Down here. The x would not be going left to right at all either. So we actually have that angle as well, which is 3 pi over 2. Now remember, with this trig stuff, we just keep rotating, right? And I can keep falling on that straight up and down or straight up. Right? I can keep landing on it. So we have all these different angles, but it doesn't exist anytime it is a pi over 2 or 3 pi over 2 or something equivalent. So if I'm looking at my xy table right there, negative pi over 2 goes this way, right? And lands straight down, meaning that x would be 0. So I cannot do this. So we're just going to call that undefined. I can't do it. The cosine is 0 at that point. Now, negative pi over 4, we can actually come up with values. How I come up with my tangent values is I use my sine and cosine values. So I don't have to memorize them. So I'm going to try to find a tangent. We'll write this here. Sorry for my notes being all over. Of negative pi over 4 is going just to be sine of negative pi over 4 over cosine of negative pi over 4. Now we go back to our unit circle. Which quadrant is negative pi over 4 in?
4.
It's in 4. So I'm going to erase what's over here for a moment so I can have more room. It's in quadrant 4. Goes down this way. All right, that's negative pi over 4. And then for me, what I think about are the triangles, right? Is it a short triangle, a middle triangle, or a tall triangle? It's right in the middle, right? Middle of a triangle. I have my 3 values. Remember, they're 1 over 2, square root of 2 over 2, and the square root of 3 over 2. I have those 3 values. This is the middle value. That tells me that these sides of this triangle are the same, and they're the one in the middle. Right? Remember, pi over 4 is that diagonal triangle where we get x and y being the exact same. Now we ask ourselves, okay, I know it's going to be pi over 2 in the numerator and in the denominator because x and y of this triangle are the same. All we got to do is consider signs now. And I don't mean SIN, right? The SIG and the positive, negative stuff. We're down there in that quadrant. Sine is y. So is the sign negative or positive?
Negative.
It's negative because it's going down, right? The y. So I know the sign is negative. Cosine. Positive. It's x, right? It's going to the right. That tells me that my tangent of negative pi over 4 is negative 1. Right, now we got to do 0. I'm using sine over cosine, so sine of 0 divided by cosine of 0. Sine of 0? 0. As long as the denominator is not 0, we're good. If we get it divided by 0, then it's another undefined. What is cosine of 0? Remember graphing that we did last week? And it was the wave? Cosine started always at 0. Or sorry, sine always started at 0. Cosine always started above, at 1. So I know this is 0 over 1, which saves us to be a 0. All we had to make sure was I'm not doing 0 divided by 0. Pi over 4. The only thing that's going to change for pi over 4 and what we did over here is the sign part, right? I know it's still going to be these values that I have right here. The only thing that's going to change is the quadrant and the sign. Well, so sine of pi over 4, cosine of pi over 4, we'll write this in notes for notes' sake, but we already know it's going to be a radical 2 over 2, radical 2 over 2, and then the signs, okay, so positive or negative, sign is y, we're in the first quadrant, right? Pi over 4 is right here. And we're dealing with y. Is y positive or negative in this quadrant? Positive. So I know that's, I'll put a plus there. So tell us that we did it. Cosine is the x in this quadrant. And in this quadrant, that would be positive as well, right? To the right. So that means this is equal to positive 1. Okay, so we're picking up on something that maybe we need to write a side note on. And I'll write it on the board, the whiteboard. I know tangent of pi over 4 is 1. And I don't want to do the sine cosine thing every time. It's annoying, right? I'm going to do it, figure out each one, and then divide them. I also knew that tangent, we did this, negative pi over 4 was 1. Negative 1, right? If I take any over 4, so if I do tangent of, okay, pi over 4, the next one is 3 pi over 4. I get a 1, again, and I just got to determine the sign. What quadrant is that in?
3.
Careful. 0, this is pi. Or I could think of pi of 4 pi over 4.
Oh, it's 2.
It's right here. Right? Flashcards, make them. I'm telling you, this stuff doesn't go away. I know it's up here. I know that I get the same, it's going to be a 1. I get a radical 2 over 2. And now I just got to determine, okay, y in this quadrant, if I put a point up here maybe, y is positive and the x is negative. So if I'm dividing, y divided by x, is my 1 positive or negative? Negative. Think about it a little bit up there. Y is positive going up, x is going to the left, so if I divide them, positive or divided by negative, I get negative. What I'm trying to get across to you is that all these tangent functions of anything over 4 is one of two values. What are those values? 1 or negative. So if the tangent's right in the middle, over 4, it's 1 or negative 1. So all you got to do, though, is draw a picture. Where is 5 pi over 4? Third quadrant, right down the middle. I already know it's a 1. I just got to determine, is it 1 or negative 1? The y value here is negative. The x value is also negative. So a negative divided by negative is a positive. All you got to figure out when it's an over 4 is what quadrant it goes in. There's also a pattern to this. Tangent, so we'll do tangent here. In the first quadrant, what was it? Positive. So it's greater than 0. Tangent in the second quadrant? Negative. Tangent in the third quadrant? Positive. And then tangent in the, we haven't done this one. Sorry, it's getting worse towards the bottom of my handwriting. The x in this direction, if I were to put out a triangle, right? The x is positive, going to the right. The y is negative. So negative divided by positive is a, do you see the pattern? Positive, negative, positive, negative. So the over force, I would recommend doing this, but I showed you how to get out of it, right? If you don't know it, get your sines and cosines down, then it won't be a problem. Okay, so that'll help with here. What about pi over 2 on the tangent, after I took that big tangent? It's undefined, right? So tangent functions are always undefined over 2's. Anything over 2, unless it reduces to something else, it's undefined. So now we can think of the domain, and we'll talk about it. How should I do this? We'll just do it in this one period here. So the one period is negative pi over 2 to pi over 2. If we were to graph all tangents, you get the same picture. Do you see the picture here? We get that same, when I was teaching high school for a handful of years, my students then were calling them pieces of spaghetti. They were on drugs though. So, sorry for my drug joke that didn't land. It has a repetition of periods there. Normally the first period, this is a big one here. We always define it between those two values. Negative pi over 2, I'm going to zoom that in for you guys. Negative pi over 2 to pi over 2. Anytime they ask what is tangent defined on, it's going to be negative pi over 2 to pi over 2. And the reason is notice on our graph here, that's when the periods start over, right? I could also say that tangent exists from pi over 2 and then the next value. Can you guys tell me what the next value would be? So I would have this like tangent function like this, and it would start over. What do you guys think? Not pi. Pi, it's defined, right? We're looking for where it's undefined again. We actually already talked about it here too, right? We said, here's our x, and it said it wasn't defined up here, and then that was this angle, and then I said, okay, there's another one that goes all the way around here. Yeah. So the next value here is a 3 pi over 2. What's the next value, do you think? 5 pi over 2? What's the next one? 7 pi over 2. We're counting by 2's, right? By odds. What's the period then? Remember, the period is how long does it take for it to repeat itself? You said it earlier. Somebody over here, it's hard with the math to see who's talking. And maybe you meant the period. Pi. Notice that it takes a whole pi to go through the whole tangent function. Then it starts repeating itself. This makes sense. Think about this thing. I am going to get like all my values of tangent from here to here. Because I get all the negative values down here, and then I get all the positive values up here. Then all these values that existed down here, I'm going to get again up here. Right? It's just like a circular thing, but instead of it taking the whole circle to repeat itself like sines and cosines, it only takes half to repeat itself. And that's just the nature of the sines and cosines being positive and negatives. All right, let's fill in these spaces. The range here is nice and easy. It's all real numbers. Right? The graph is undefined at the values of the form. So how we do this is we say pi over 2 plus n pi. I'm going to write it, and then let's talk about why that makes sense here. It's undefined at over 2, right? And then I know when I add a pi, it hits another over 2. Think about our circle right here. Pi over 2 is right up above, right? If I want to get to the other over 2, I have to go halfway around. What is halfway around the circle in radians? Pi, right? So if I'm here and I want to get to the other over 2 where it's undefined again, I would add pi. So this becomes 3 pi over 2. What if I wanted to be, okay, pi over 2, and I want to go all the way around? How many pi's do I have to add? 2. So that's where this n is coming from. 1, if I let n be 1, I got pi over 2 plus pi. That gets me from this, right, straight up and down to down here. Now, what if n was 2? How many circles would I make? So that would be plus 2 pi, right? How many revolutions is 2 pi? One revolution, right? Yeah, so if I let n be 2, I'd be here and I'd add 2 pi and I'd land back on. Right? What if it was 3? 3 pi. How many revolutions is that? 1.5, right? 3 pi, right? Halfway is pi. So if I started at pi over 2 and I went 1.5, here's 1, and a half gets me back down there. So what this does is you pick your favorite n, any n that you want, you plug it in, this is guaranteed to land either up top or on bottom. It hits them all for any n. Right? And then they have vertical, and I don't know if you guys remember this word. Does anybody remember that dotted line word from pre-calc 1? Asymptote. Yep. We'll try to fit that in that space here. Right? The X-intercepts have values of the form. So now let's look at this and see if you guys can help me come up with an equation here. The X-intercepts are right here and right here, right? And they keep continuing forever, right? I have them on the graph there, right? You can see them. Just repeat them themselves. So this starts at 0. How often does it repeat itself? Meaning, like this first blue dot here, how long does it take to get to the second blue dot? Pi. So this is also in pi. You pick your favorite n, plug it in there, and I'll tell you that this angle will land on an x-intercept. Starts at 0, and it repeats itself every pi. The period then is pi. There are no minimum or maximum values, so the graph has no, I think this is what they want here, extrema. Right, the graph is symmetric with respect to the origin. Right, if we think about the origin, if I think about the tangent function just there, the black one in the middle, I can spin it, right? A propeller. If I spin 180 degrees, just 180 degrees, I land on itself again. If you look at it, now from pre-calc 1, do you guys remember the definition of that? If you had me, this is a definition I would skip over, I'm sorry. This is called an odd function. If it's, I'll write these out. If it's symmetric to the origin, it's an odd function. If it's symmetric to the y-axis, you want to take a shot at what that's called? Even functions. These keep coming up. Right, with this definition, we actually get this property of tangent negative x is actually the same thing as negative tangent x. If you're unsure about that identity, stare at the graph for a while. Think about if you were to take an angle on the right side and make it negative, you would get the same value, but the negative value. It's because it's symmetric about the order. I would think about that a little bit. You can actually go forward without not remembering that, like meaning that's not going to come back up, but they are nice definitions to know. Okay, cotangent function. Nice and easy, right? It's the exact same function, just flipped horizontally and shifted over. So the domain here is from 0 to pi. That's where this function starts repeating itself. The range goes up and down forever, so this is all real numbers. We get the same values from this stuff. At 0, it's undefined. We could, if I wanted cotangent values, and I was looking at the graph, like the table here, and I wanted cotangent, what could I do with all those values? What's the relationship between tangent and cotangent? Reciprocal, right? Means if I wanted cotangent of 0, well, what is 0 flipped over? Undefined, right? So that means if I want cotangent of pi over 4, and it's 1, and tangent of pi over 4 was 1, what does that mean about the cotangent? It's also, what's 1 flipped over? 1. Pi over 2 for tangent. Remember, tangent for any pi over 2 was undefined. I don't know if you guys remember this from doing like slope in pre-calc 1, but when I have an undefined ratio and I flip it over, what value does it get?
0.
0, yeah. Tangent of 3 pi over 4. Right? I'm just thinking of my signs. I know it's a 1 because it's a 4, right? Over 4. And then I get this relationship, okay? 3 pi over 4 is in second quadrant, which means tangent is negative. Which also means the cotangent, negative 1 flipped over, is negative 1. And then pi is undefined. The way I got these down is like straight memorization for me. I memorize these 3 values, the undefined 1, 0, negative 1, and that's how I have these graphs memorized, is I think through it that way. And then if I can't remember, I use the definition of sine over cosine. I do not memorize my tangent values. I still don't. So there we go. Let's fill in the spaces. The graph is undefined. At values of x of the form 0 plus in pi. Look at our picture here. Those undefined moments are the straight up and down lines, right? They are repeating themselves every pi, just like tangent. So I can actually hit any of those as long as I just take 0 and add a pi over and over. Or subtract. And it has vertical, these are called asymptotes. X-intercepts have the value of, what do you guys think? Where does the X-intercept happen here? Just on this one period here, one phase. What value does the X-intercept happen at? Don't think too hard. Pi over 2. Right, so this value, right? That's what I was asking for. Where it crosses the 0. And then that's the only value in that period. So I'm not going to hit it again until I go through the whole period again. So that means if I want the next value, I'm going to add in pi. If I want the next one, I add 1 pi. If I want the one after that, I add 2 pi. If I want the next one, I add 3. If I want to go backwards, I just start subtracting pi's. So what is the period here? Pi. All right, there are no minimum maximum values, so the graph has no extrema. The graph is symmetric with respect to the... Do we really have anything here? Let's mark that out. I don't think there's symmetry there. I don't know what stretch your curriculum is trying to make either, but it's not there. There's no symmetry. Okay. You can tell that was bad curriculum writing anyway because they have tangent there at the bottom, so they copied and pasted. All right, the period stuff here works a bit the same as what we did last week. It's just now we're going to be dealing with a different function. Let me make sure I get these formulas perfect from what your curriculum says. This is 6.5. Sweet. Okay, so to graph those functions, find the period, and this is, do you remember what we did with sine and cosine to find the period? We took, what is the period for sine and cosine? It was what the whole thing, right? All the way around. 2 pi. All right, so we got to start getting that in our head. The period for sine and cosine is 2 pi. Tangent, cotangent is pi, 1 pi. So what we did to find our period for sine and cosine is we took the whole period and divided it by b. Well, in this case, it's close to that, except for we don't take 2 pi, we just take pi, because pi is my new period. I think the equation I wrote every time last week for that, I wrote period divided by b. All right, for that first function, okay, to locate two adjacent vertical asymptotes, solve the following equations for x. So we get b of x equals negative pi over 2. We're just going to use these formulas. And pi over 2. For cotangent, we get bx equals 0 and bx equals pi. This makes sense if we think about tangent, right? Tangent happens, the asymptotes happen at pi over 2's, right? So if I just set the angle, this is the new angle that tangent's going to be. I'm going to say tangent of bx, right? That's the ratio I'm going to find. If I want it to be an asymptote, that means I want this b of x to be pi over 2, some sort of pi over 2, because I know from above that tangent is not defined at pi over 2. So if I can make the angle inside pi over 2, that'll tell me where these are at now. Same thing with cotangent. The asymptotes happen at 0 and pi instead of the pi over 2's. So we just set our inside an angle to both and solve for x. All right, let's fill in the rest and then we'll get us a couple sketches. I don't like steps, but I want to give you them if you want them. Okay, so step 3 says divide the interval formed by the vertical asymptotes into 4 equal parts, just like sine and cosine. All right, then we evaluate for those points. And then the last thing says join the points with a smooth curve approaching the vertical asymptote. Plural, asymptotes. All right. There are the steps if you're a step person. I'm not. I can't memorize steps. Just doesn't work for me. So I just kind of figure out what I need to do as I go along. All right, so step 1, we'll follow them here. It says find the period. So my new period is pi over b. Period is equal to pi over b. What is b? 2/3, right? It's the number in front of x. So I got pi divided by 2 over 3, which is just flipped over, right? 3 pi over 2. Right? If I want to find the vertical asymptotes, I'm going to run out of space here, but it's okay. I'm going to set bx, so that's 2/3 x, that's what they're talking about, bx, equal to negative pi over 2. And then I'm also going to do an equation, 2/3 x is equal to pi over 2. These are going to tell me where the asymptotes are. All I got to do is solve for x. So the first equation, I solve for x. I get negative 3 pi over 4. My pen, I got to replace this cap. Negative 3 pi. So what I'm thinking about here is I'm multiplying by 3 over 2, right? So I get over 4. Just solving that equation. I multiplied both sides by 3 over 2. Same thing with here, except for now I'm just going to get a positive 3 pi over 4. The whole point of this is this finds my interval on the graph. So I'm going to do over here, negative 3 pi over 4. And then I'm going to do it over here, 3 pi over 4. These are my asymptotes. All right, I split it right down the middle because I know that tangent is defined right in the middle. At 0, it's that piece of spaghetti, right through the middle. And it says to divide it into 4 equal parts. So if I were to divide into 4 equal parts here, I need half of 3 pi over 4. Anybody tell me what that is? Do you guys know how to half a fraction really quick? Don't write this down. 1/2. What's half of 1/2? 1/4. What's half of 1/4? What's half of 1/8? 1/16. What's half of 1/32? Or sorry, 1/16. This is 1/32, right? What's happening as we go along? We're multiplying the denominator by 2. So what is half of 3/4? 3/8. What's half of 3/8? 3/32. So whatever the fraction is, if I want to half the fraction, all I got to do is double the denominator. Okay, so looking up here, I got 3 pi over 4. I want to take half of it. So what is my new asymptote? 3 pi over 8. Or use your calculator. If you need to take 3 over 4 and divide it by 2, go for it. This is negative 3 pi over 8. I have now split my interval into fourths. I know my values here are 1 and negative 1. And then I just plot it. Okay, at 3/8 it's 1. At negative 3/8 it is negative 1. And then it does something like this, right? Something through here. Mine's not the prettiest, but there's the graph. So I know it's always the midline. And then a quarter of the interval up. Corner of the interval back and down. Let's talk about what changes values. The period we just did, different. What would change the 1 and negative 1? Like, let's say I wanted 1 and negative 1. In this case, I want to put a 2 and negative 2. What would I change about my function to get a 2 and negative 2 instead of the 1 and negative 1? You put a 2 in front. That's it. Right? So if I want my amplitude, it's amplitude. It doesn't cap there, right? So there is no amplitude or extrema, but I can find those values based on the amplitude. Amplitude, right? Number out front. Okay, so there's that whole point, or whole graph. I don't like steps. I like to repeat the same process in asymptotes, split it into 4, and then pattern, right? In the middle, and then up on the right, down on the left. Let's do another. Questions? Concerns? Complaints? All right. Example 2. First thing we're going to do is find our period. To find my period, I take my existing, what it would have been, which was pi, and I divide it by b, b being the number in front of our argument being the 2x. So b is 2. So I know my period is pi over 2. I can find this now by taking b of x, 2x equals negative pi over 2, and 2x equals positive pi over 2. These will tell me my new asymptotes. So I got x equals, this is negative pi over 4. I'm just cutting it in half, right? We're good at that now? Right, there's that. And this is also pi over 4. So those are going to be my asymptotes. Negative pi over 4. And then pi over 4. I split my interval up. I know there's a 0, 0 in the middle. And then what are the other two values?
Pi over 8.
Good. Pi over 8, half of pi over 4. I know the values here are going to be 1/2 and negative 1/2. Right, the only thing that's different, we took care of the 2x, right? The 2x we took care of right here. That's how the 2x affects our graph, is it changes the period. We dealt with the 1/2, that was here and here, right? Those are my new quote-unquote amplitudes, right? The only thing that we haven't thought about is this negative. What does a negative in front of a function do? Which way? Flips it down, right? I always think of the parabola. Parabola is the easiest one for me to remember. If I have a negative x squared, it just goes over the x-axis. So instead of, like here are my points, I'll do them in blue here. I have a 0, 0 here, and usually I go up here, right? But instead, since it's all negative, my points are just flipped. And then I do my best to sketch that tangent function. Again, on test, you will be doing matching for this, right? Or I'm going to say, tell me the period. Something like that. Tell me this, tell me that. I don't like grading graphing. It's tough. It's really hard. It's not great for you. It's not great for me. So I just cover it with matching, multiple choice, or details. Like what would the X-intercept be or something like that. How you feel? It's not too bad. All right, let's do another. But now it's cotangent. All right, cotangent, my period for cotangent is pi. All right, so to find the period for this thing, it's pi over b. B in this case is 1/2. So what does that equal to? 2 pi. So that's my period. To find my new asymptotes, right? Remember, this is cotangent. So cotangent's different. I take the bx and I set it equal to the cotangent asymptotes, which are different. They were 0 and pi. Cotangent had different asymptotes. Tangent had negative pi over 2 and pi over 2. Cotangent is shifted to the right. So to do those, my period is 0 and then 2 pi. Okay, so go all the way to 2 pi. I need to split this into force. Let's do our asymptotes first. At 0, 2 pi. And then I cut up my axis. Halfway between would be pi. Halfway between that is pi over 2, which means this is 3 pi over 2. Up and down values. I have a 3 and a negative 3. Now, if I go back and look at my cotangent function, right, looking at my box up there. So it's not exactly tangent, it's shifted over, right? It's flipped as well. So that means when I go over this way, it should go up. So here's my sketch. I know that this middle function will still be in the 0. And then I know it goes to the left up to the 3. Right down to the 3, and then we try to maintain the curve there I missed. The higher the amplitude, the more linear it looks, right? The bigger we think that it stretches out. Think about that curve doesn't have to happen so fast. But if the amplitude was down here at 1/2, those curves would have to happen really quick, meaning the curvature is steeper, right? But if the amplitude's up high, it stretches my function out a little further. The curves aren't as steep. I prefer graphing these over sine and cosine. I think they're a little quicker. Questions? All right, let's take a look at 4. What's different about this one? The negative 3 is being added, not multiplied this time. When I had something like this, you don't need to write this down. If I had this function, and then I had this function, What happened to, if I'm comparing the second one to this one on the graph, what happened?
It moved up 3 units.
It moved up 3 units. So what do you think this is going to do? Down 3 units. The same thing as functions did in pre-calc 1 and in sine and cosine stuff. It just shifts it up and down. So the period, go through the same thing again. The period is pi divided by b. That's nice. Didn't change. Period's pi. If I set that equal to both of these, it tells me exactly where the asymptotes are because I don't need to divide by 1. So there we go. I got negative pi over 2 and pi over 2. My dotted lines for my asymptotes. Right? I know tangent starts right in the middle and then cuts it in half. So I know this is negative pi over 4 and this is pi over 4. How tall is the amplitude? 1. Something happened though. That negative 3 changes things. So maybe I don't want to put 1, negative 1. Right? I would actually need to get down to that negative 3. That's my new midline. So what I'm going to do is this. I'm not going to do that. I'm going to go ahead and cut these into thirds. Actually, I need to do more than that. Let's cut it into whatever that is. 5, 2, 3, 4, 5, 6. We'll do that. My new midline I'm going to do in dots is at negative 3. There's not a horizontal asymptote, but I like to put it there. Just to kind of help me out. Now I know that's where my function goes. It starts right in the middle. What is the amplitude of this thing? 1. So that means I go down 1 and over 1, up 1 and over 1, and then there's my graph. Notice the curve happens a lot steeper. This is what I was just talking about. The lower the amplitude, the sharper the curves towards the asymptotes. So don't miss the midline thing that the negative 3 just brought it down. That horizontal line is not an asymptote. It's just a reference for me. Okay, questions, thoughts, concerns, complaints? Cool, a little further, bear with me. All right, so we know what this does. This shifts it up 3. What do you think that does inside?
Moves it left pi over 2.
Left pi over 2. So these we have those translations, up 3, and then left pi over 2. And then we have that same stuff that we were dealing with, the period. All right, now how the period's still the same. I do pi divided by b. What is b in this case? 1. Right, so it's pi. Now, to get my asymptotes, there's a little bit more to it. I want bx, whatever that's going to be, inside this whole thing. I'm going to set the whole thing equal to negative pi over 2 and pi over 2. Well, we're dealing with cotangent, right? So what should these be then? 0 and pi. Remember, tangent was negative pi over 2 and pi over 2. That's where those happened. But cotangent happens at 0 and pi. So I set those equal. It's the same process, solve for x. How do I solve for x in that first one?
Subtract pi over 2.
Right? Subtract pi over 2. So I get negative pi over 2. Pi minus pi over 2 is pi over 2. All right, use your calculator if you need to. 1 minus 1/2. No shame. Those are my new asymptotes. So I'm going to graph those. I also want my reference for my midline. I like that. Where does that happen? At 3. So I'm going to go up 3, 4, 5. I'll do 5 there. So 3 is my reference line here. It's just a midline. It's not an asymptote. I'm going to cut my interval up into 4. Luckily, it's symmetric about 0, right? So we get pi over 4 and negative pi over 4. Cotangent is going to start right there in the middle of my period. And then remember, cotangent doesn't go up to the right, it goes down to the right. So I go over 1 down, and then that tells me exactly what to do on the other side as well. Since the amplitude is a 1, or quote-unquote amplitude is a 1, we expect sharp curves. If the number was bigger, the curves wouldn't be so sharp.
What about the shift?
We took care of it right here. Yeah. It feels like it's not shifted because it's in the middle, but remember we're dealing with cotangent. Cotangent's to the right. So since we shifted to the left, it moved it right in the middle again. The good thing is, mentally, the setup is the same for these, right? You set it equal to the asymptotes and solve. Understand as well that we're only doing 1 period, right? This isn't the whole graph of this function. The whole graph would actually, right, forever on, both sides I'd have it going on, right? Forever going one way going the other, but all we care about for this, because the point of this is application for the real world, right? You guys are heading towards physics class, take calculus, apply it to the real world. In the real world, typically we care about 1 period. We can get all the relationship we need from 1 period. All right, let's switch over to 6.6. Before we jump to that, I do want to give you guys a schedule update, just so we're all on the same page. Sorry, I had this pulled up and it closed on me. There's a schedule online if you haven't noticed it. It's in Blackboard. There's also a due date thing I made up there. My other classes wanted it, so you guys get it as well. Let me go to my schedule, and then I'll write these dates down, because we have a test coming up. Your take-home, hopefully I can get back to you guys within a week. I'm trying. I have all 4 classes had assessments at the same time. And then I was going to grade yesterday, and then I drank a Bloody Mary and lost all motivation. So it didn't happen yesterday, but in the next couple days, I will get those to you. Pre-calc 2, going to my schedule. All right, so what this week looks like is we are about to do 6.6. Load. So Wednesday, we'll finish up this section if I don't finish it now. 6.6. We are not going to do 6.7, even though it's on the schedule. I took it out. We can live without it, and I wanted to give you guys a breath, right? So we're not doing that, which means on Wednesday we'll finish that up, and then I will do a test review for you. What that's going to look like is in the next few days, I will make a test review, usually 30 problems-esque, and this is how you prep for your test. What I usually do is I make a review, and then I write my test based on the review. So no surprises for me. I'm not that kind of test giver. We have too much test anxiety to deal with that, right? So you'll know exactly what's coming. You just have to prep. If you can do all the review problems that will be up there without any help, you'll be set for my test. I hate to give that's the goal, do all of it and you'll be good, but genuinely, I pick from the problems from the review, change the problems, maybe change it slightly, but the difficulty won't be worse than the review. Is that okay? So what that means for Wednesday here in class is if I have to finish up 6.6, which, what time is it? 11:53. We may get done, maybe not. I'll finish that up, and then the remaining of the hour and a half, I'm just going to do questions. So if everybody shows up or nobody shows up, nobody asks anything, we'll be sitting in silence. My advice to you is if you can, I know we all have lives and other classes, if you can do all of what you can do on the review before Wednesday, make a list of the questions you can't do, I'll do them all up here for you. But if you don't bring anything, we just sit in silence and I plan. Okay, so bring your questions with you. With that, if you don't want to come to class and you just don't need it, you can prep on your own, you don't have to come, right? Attendance, I don't do attendance grades. So if you don't feel like you want to come and watch me go through problems or sit here and work in the same room with me, you do not have to show up. With that, we have a test on Monday. Also, my dates on the schedule are off. I got to fix that. I have spring break in the wrong place. So Monday will be Unit 1 exam. This will cover sections 6.1, 6.2, pen's going out, 6.3, 6.4, 6.5, and 6.6. I guess I could have put 1 through 6, right? But here we are. I think I got in the habit because my Calc 3 and DE, we don't do it in order. Okay, so that's what the exam's over. The review will cover all those. Do the homework and the review and you'll be set. Please come get help, right? Before Monday, come get help at some point. This Friday I will be on campus, so you just got to tell me you're coming up here. I'll be working, but you just let me know you're coming. Okay, questions? Okay. Note-wise, like any kind of notes, I'll decide before then. I'll let you guys know in the next few days if I decide to let you have a note card or something like that. Sometimes I do, sometimes I don't. But I want to write it first and decide if, like sometimes if it's just one formula, I just write it into the problem, right, and give you the formula. So let me look at it. If it's a bunch, I don't want to do that. You guys could have a sheet of paper or something. But let me go take a look and see what this, remind myself of what this exam covered, this unit. So, okay, let's take off on 6.6. All right, we have 2 more functions out of the 6 that we haven't looked at graph-wise. The good thing about these 2, we're about to look at secant and cosecant, is you graph sine and cosine, and then use that graph to graph these new ones. So, you already know how to do it, right? We already went over it, meaning I don't know if you've practiced yet and got there, but it's no new skill except for applying at the end. So, let's take a look at this. The domain for these things, for secant, is negative infinity to negative 1, 1, and these have brackets. Yes, they have brackets. Oops, that is our range. Forgive me. Negative infinity, you can do arrows if you want. Negative 1, union 1 to infinity. That's my range. My domain. How could we write this? Let's do one period. So here's one period. So the domain here is negative pi over 2 to pi over 2 union pi over 2 to 3 pi over 2. You can kind of see the pattern if you were to keep going, right? I could do another union and then be 5 pi over 2 to 7 pi over 2. I could do another union and keep the pattern going, but we're only going to look at one period here. Right, let's use the graph to figure out these values to make our life easy. Negative pi over 2, what do they have on the graph there? That's this dotted line, right? So that means this is undefined. Good? Pi over 4. All right, well, I know secant is cosine. Oh, it flipped over, right? Sorry to write this backwards here. It's flipped over. This is 1 over cosine flipped over. What is cosine of negative pi over 4? All right, so we're looking at our unit circle. First, what quadrant is that in? Negative pi over 4. It's in 4, good. Because it went down, right? Which triangle is over 4? The middle triangle. My 3 values I look at is 1/2, rad 2 over 2, and rad 3 over 2. The middle triangle, x and y both have square root of 2 over 2. So I know this is the square root of 2 over 2, and then cosine is my x or y. It's my x. In that quadrant, is x positive or negative? Positive. So this thing is 1 over rad 2 over 2, which is just 2 over rad 2. If I rationalize this thing, which I promise to you guys, you don't have to do this after this semester, you get to quit doing that, you get rad 2. Sure that makes sense to you. You get 2 rad 2 up top, then you just get a 2 on the bottom, the 2's cancel. I'm sure you can follow that. So that's rad 2 here. 0 is 1. Then we get rad 2 again. Then we got undefined again. Oh wait, I went the other way, didn't I? Okay, so... Nope, we're still good. We're still good. Okay, so this is undefined again. All right, because that's that red dotted line. Then at 3 pi over 4, that's right here. You can tell with symmetry, what do you think it would be? Negative rad 2. Pi is -1. 3 pi of 2 is negative rad 2 again, just based off symmetry. All right, the graph is undefined. At values of x of the form, so I start with pi over 2, that's where it started, right? That's that first red dotted line that I have here. That's pi over 2. How much do I add? So it's going to be n times the period. How much do I have to add to get to the next one? And it's weird because the period's not pi here. But if I'm at, and they're talking about the undefined portion, so that's like right here, right? This straight up and down line, and we want to know what do we have to add to get to the next one. That's pi. Right? Think about pi over 2 to 3 pi over 2. Think of the circle. It's easier to think about. I'm here, right? And I want to end up, down here. So how far is that rotation? Pi. Half, right? Half the rotation. So if I'm at pi over 2 and I want to keep jumping over, I just keep adding pi. And that's why we add plus n pi, because the n is just a random variable that tells me how many times do you want me to go right or left. Right? It has vertical asymptotes. Spell them right. There we go, I think. There are no x-intercepts. The period is 2 pi. That's when it starts repeating itself. There are no minimum or max values, so the graph has no, I guess we call amplitude or extrema, either one. Right? The graph is symmetric with respect to the y-axis. That one actually does have symmetry. So the function, okay, which one is that, even or odd? Even. And then we have that secant of negative x is the exact same thing as secant of x. To understand that last thing, just look at the graph and think about if you were to plug a number in on the right side and compare it to the left side. Because all the negative x means is like, what this means is if I have a graph, right, and I have a 3 over here, and I want that value, a negative x just means what is it over here? Well, if it's symmetric, right, here, let's just say this is my graph to keep my life easy, okay? It's symmetric, right? So the value, if I had secant of -3, this is the same thing as secant of 3. If it's symmetric across the y-axis, it's a mirror, which means, yes, these things are going to be the exact same thing. That's what the symmetry means, right? Of the y-axis. All right, that's secant. Let's take a look at cosecant, and then we'll graph a few of these monsters. Okay, this has the exact same domain range, except for things are moved around a little bit. This first one is going to be 0 to pi, and then pi to 2 pi. We could throw a union in between that. We could keep going with more unions if we wanted to on either side. The range is the same as what we just wrote on the last one. It just skips that middle part. All right, we'll fill in all this. Let's go through and get the important parts. I have undefined. We'll also do pi over 2, which is 1. Then pi is undefined. I don't know what I was writing there. And then 2 pi is also undefined. Three pi over 2 is right here. That's at -1. So we really just need the values around it. With graphing these things, it's not important. Okay? So we're going to leave those blank. Also for the sake of time, because I'm running out. All right, the graph is undefined. Same thing. X values of the form 0 plus n pi. All right, you just follow your asymptotes and ask yourself, how much do you have to add to get to the next one? These are all vertical asymptotes. There are no x-intercepts. The period is 2 pi. Right, so since there are no max or min values, it doesn't have an amplitude or extrema. Right, the graph is symmetric. This one, got to think about it for a moment. Yeah, origin. So the function is an odd function. And then the odd function definition means that we can get negatives out. Like if the negative is in there for the argument, we can pull it out. Sorry for the little writing up there. All right, cool. There are the characteristics, but we care about how do you graph one, and what's the pattern, how can we do it quick. So here we go. Let's jump down to example 1. I'll fill in that if we have some time. If not, they're in your book. So here are the steps here. So the first thing I'm going to do is determine my period. The first thing we're going to do is graph the reciprocal function. Right? So I'm going to call it G. Right? The reciprocal, what is the reciprocal of secant? It's either sine or cosine. It is cosine. So I'm going to graph that. So my period is 2 pi divided by b, and in this case, b is pi. There are no shifts or anything like that. I just have amplitude now. Since we're dealing with just cosine, the amplitude is 3. All right, so we're going to graph our cosine function. I got 2 pi. Then I cut it into fourths. I got pi over 2, and 3 pi over 2. It's cutting it into 4. My amplitude is 3. I'm going to bring that down just a bit because we're going to graph above and below it. All right, I have all the information now to graph the cosine. I'm going to do it in some other color. You guys may want to do it in a dotted, and I'll do it in dots here too. Cosine at 0, does it start on the main line or does it start above it? Above it. So I'm going to graph that point there, and then I just follow this with cosine pattern. All the way down, then all the way back up. All right, now I'm going to graph this cosine function as a dotted function here. This isn't my graph. All right, my graph has, if I'm thinking about flipping it over, right? That's what secant is I need to think about flipping this cosine over. So anywhere there was a 0, what does that become if I flip it over? Undefined. Those are my new asymptotes. So where there are x-intercepts, I'm going to put asymptotes. Right. Here's how you graph the function. We did all the work now. I plot on the max and minimums, and I go up. So the pink graph is my graph. So we plotted the reciprocal, and then we just went to each max and min and did our little, they look like parabolas. They're not parabolas. Parabolas don't have asymptotes. So it's something completely different, but they look like them. So as long as you can do sine and cosine, you can do these. You just got to remember which one goes with which. All right, let's do another example. Everybody get caught up for a moment. Put caffeine in my body. Right, now notice 2 has a lot going on. Right, so I'm graphing its reciprocal function, so I'm going to graph that first. Call it G. What is the reciprocal of cosecant? Sine. So I'm going to do the exact same function, but with sine. Exact same as the one written. All right, my period is 2 pi. So that didn't change at all. So remember, now we cut it up, like 0 to 2 pi. We cut it in half, pi over 2, pi over 2, or 3 pi over 2. And then this is where I would like figure out my shifts here. Which way does this shift, left or right? Left, because of the plus pi over 4, right? So to get my shift, if it's going to go left, I need to take all these values and subtract pi over 4 from them. These will tell me my new values. First one's nice and easy. Pi over 2 minus pi over 4 is just pi over 4. Pi minus pi over 4 is 3 pi over 4. 3 pi over 2 minus pi over 4. I'm going fast, but it's because we're running out of time. 5 pi over 4. Wait, I'm going the wrong way, aren't I? I didn't subtract on that one. No, it was right. Sorry, brain fart. 2 pi minus pi over 4 is 7 pi over 4. I'm just thinking 8, right? 8 over 4 minus 1. So those are my values, so I'm going to plot those here. So I got negative pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, and the last one is 7 pi over 4. I'm dealing with sine. First I need to mark my amplitude. My amplitude is 1/2. And then now I graph my function. Does sine start on the midline or above it? On, right? Sine of 0 is 0. So I put that on the negative pi over 4. Sine, there's no negative, so my route goes up first, and then all the way back down, and then back up. I don't actually plot this, it's just it's a reference. So there's my reference. Right. Now what? What do we do next? The asymptotes, yeah. So all the zeros. I get my asymptotes. And then my graph just picks up from the max and mins. And we do this like parabola-like shape. It's not a parabola, but it looks like one. There's the graph for that one. All building off like the idea of sine and cosine. What do you guys think? Hate it? It's fun. That's good. Yeah, that's always a good thing for your fun. I always just go for I don't hate it and I'm happy enough. Or I only hate it a little bit. Cool. All right, let's see how, what time? It's 12:13. Maybe we could do one more. Let me, oh, perfect. Here we go. We're going backwards now. Oh, do you need more of this? Yeah, you're good? Anybody else need me to stay for a moment? Please always stop me, make me go back. You're not going to offend me. I've done prison education, and they just yell at me about it, and I wish you guys would do that. You don't have to be nice. They're like, I don't get it, and I'm going to hold everybody else up in here until I get it, and you guys should be that way. So, okay, here we go. 6, 6. All right, I have this equation. Let me zoom in here. All right, so the first thing I do is I determine my period. It's kind of what I do graphing-wise as well. So what is the period? When does it start repeating? Well, it starts here, right? And then it catches up with itself right there, across the whole thing. So how big is that? 4 pi. So I know that I could either be dealing with a sine or cosine. I'd like to not shift things, like left or right. I don't want to shift things. So if I were to fill this in, thinking about like a sine or cosine, what function is that? It's cosine. The reason we know is because at 0 it starts at 1. So I know I'm working with cosine. So I know there is, maybe we should working with cosine. Right, or cosine of x. I know I'm doing that. I also know the period became 4 pi, so that means that if, when I plugged in b, I like worked it out and I got 4 pi. Right, that's the formula for finding period. I know the normal period is 2 pi, and dividing by b gets me 4 pi. So what does b need to be? 1/2. Let's work that out for those of you that can't eyeball it. I would multiply both sides by b. So I got 4 pi times b. My b's look like 6's, so I apologize. Then what would you do from there? You would divide by 4 pi because that would get b by itself. Pi's go away. 2 over 4 is 1/2. So I know I'm dealing with cosine. The before I flipped it, I had like cosine of 1/2 x. Now, the only thing I got to think about now is the amplitude. What is the amplitude in this photo? 1. So I don't have to put a number in front. It didn't flip over or anything like that. So my function here is y equals, what is the reciprocal of cosine? Secant. So I got secant of 1/2 x. All right, let's do b. B, does it go better with sine or cosine? Sine. Right? You can tell because we don't have, like, look over here. We had this, like, parabola right on top, right? Right in the middle. Now my, like, parabola-looking shapes are, like, symmetric about. So that would tell me a sine. Symmetric about the origin. Okay, so I got to pick up a bunch of stuff. I need the period. So it's from here to here. How big is that? 2 pi. That's really nice because that means I don't need to figure out what bx is. Bx is equal to 1x. The period didn't change, right? The normal period for cosine or sine is 2 pi. I don't need to figure out what b is. B is 1. Amplitude. Right? So we do have some stuff here. This gets a bit weird. Notice that this is, if I were to draw the function, it looks like something like this. There's my sine function. It's not right in the middle, right? Like this point right here is not at the origin. So that means it was shifted down. How many was that shifted down? 1. Okay, so I know that I need a -1 on the outside. Keep that in mind. Now, the other thing we have to do is figure out our amplitude. How far did that go up and down? 1. So A, or amplitude, is 1. There is a shift down 1. There's no left or right shift. So that gives me enough information. So this would be, we're working with sine x. And then with all the information that I just got, this is sine x with a -1. I'm going to put the -1 out front so it's clear that it's not with x. Right? I could put it at the end, but you just want to make sure that nobody's thinking x minus 1, because I'd change it. Right? But we don't have that. My function is the reciprocal of sine, which is cosecant. There we go. Nothing else changed. I think that's a great stopping point. I don't even know if I put something after that. I did not. Perfect. Okay, so on Wednesday, I will be doing a review in here, meaning if you show up with no questions, we sit while you work and I plan. Show up with tons. I would rather you take up the whole hour, 20 minutes with questions. It makes the time go by faster for me, and I help you. If you don't feel like you need to show up, that's great. Just email me questions. Come see me during my student hours, whatever you need to do to prep. I will have the review up before Wednesday. Goal is today. That way it gives you plenty of time for those of you that want to try to get done by Wednesday. Have a good couple days. I'll see you guys on Wednesday. Come get help if you need it. Don't hesitate.